Over 100 years ago, somebody in the newspaper wrote, "A picture is worth 1,000 words." So if you add some simple math to this fact, you can end with over 3 million of resilience examples. Me and Christopher Nolan, specially for you, prepared a 2 minutes examples of resilience.
There are 400,000 men on this beach.
He's coming back round. He's coming back round!
Where are we going? Dunkirk.
I'm not going back.
There's no hiding from this sun. We have a job to do.
If we go there, we'll die.
You can practically see it from here.
What?
Home.
Developers from the British Expeditionary Force, you are here in Dunkirk and you are surrounded by the enemy. There is only one way to survive, the sea evacuation to your home country. But we don't have enough warships and the bay is too shallow. It's time for Operation Dynamo. You need to use little ships of Dunkirk, about 850 private boats. They are distributed and available via Boats API. Please use this API in a responsible and resilient way. Good luck. Hello, my name is Tomasz Skowron and today I will tell you not only how to survive on the beach or on the sea full of enemy fighters or bombers, but also how to survive as a developer in the non-resilient war, when each event potentially can kill your system. Why do we need to think about resilience? Because even small failure, even an important one, can be beginning of big, long and hard failures chain. Why do we need to think about resilience? Because it is enough to have client-server architecture implemented to have distributed system. Why do we need to think about resilience? Because as developers, we often forget about error handling. And I'm not thinking about exceptions logging or throwing them into faces of your users. I think about error handling that can help all restore your system. Why do we need to think about resilience? Because if some part of your system doesn't work, it doesn't mean that you can't provide this feature. You can try to provide it in simpler way or some partial solution. My examples are prepared in Java because I am a Java developer, but you can find a lot more resilience libraries. Why do we need them? Because it doesn't make sense to implement each pattern as a new component. You can create components using some popular libraries, like Hystrix one for Java, but because Hystrix is dead, he is no longer under active development. It is in maintenance mode for 1 year. My examples aren't prepared in Hystrix, but in its successors named Resilience4j. It is a lightweight solution. In contrast to Hystrix, it has not 3 but only 1 dependency, Waiver library, Java library for functional programming, but it isn't part of public API of this library, so we don't need, you can, but we don't need to use it. Let's begin with some examples. Probably the simplest pattern is time limiter. Everybody heard about timeouts. So what is time limiter? You can think about it as if it were a timeouts factory. But wait a moment. Isn't a timeout some kind of error exception? Why do I need to provide them? First, you are right. If you receive timeout, that means there is some error exception. But let's imagine what could happen if you don't have timeout. You won't know because you will still waiting. Wait. So what you can do with timeout limiter? It is enough to provide future supplier, and you can add and configure and add some timeouts to it. Let's see the example. How Resilience4j works. It works for all components. What you need is a configuration. You could use a default one, but don't do it. Even if you know the default values, it doesn't mean that other guys from your team know them. So in this case, it is very simple pattern. So only what you need is timeout duration. And when you have your configuration, you construct your time limiter. You can construct your time limiter. And now what you need is to decorate your function. Resilience4j isn't maybe functional library because it is difficult to say about pure functions in world of timeouts, retries, and network. It isn't functional library, but it uses functional interfaces from Java. So what you need is to create a component like this one and wrap any function like this provider supplier. Time limiter is a little different, but in case of other components, you can decorate not only future supplier, but also each supplier, callable, runnable, or future. And you can be surprised with this try. What is try? Try is a monad like optional, but from waiver. And instead of writing this kind of code, yes, we don't want it. So instead of writing like this, we use try and wrap the result. It is similar to optional, but in case of failure, it isn't empty. It contains the reason of failure, the exception. And what time limiter do? So we say there is some our business logic. It takes 42 milliseconds, and we wrap it, decorate with time limiter, and execute here. And the result is 42 because it is there is no timeout. If there is longer executions, there will be timeout and timeout exception. Simple. But let's switch to another pattern. It is rate limiter. This time it is also about time, but here time has different meaning. It doesn't limit the duration of execution of your method, call, whatever, but it limits the number of executions per some time window. So you can think about rate limiter as if it were a throttling factor, because with rate limiting you can simply add throttling to your clients, not only to your servers but for your clients. On the first plan, the blue lines show situation without throttling. You can see that there is no limit, but when you apply throttling, like using rate limiter, the number of executions per each second is 1000, no more. So you can limit and protect your resources. Let's see the example. There is our configuration. Our time window is 2-second window. We permit for 1 executions per this window, and it is almost all. And here we execute our decorated method. There is our method, there is our late limiter, so it is decorated, and call it twice. And there is no surprise. Well, if we permit only 1 call, the first one is permitted, the second is not permitted. But in the second case, when we add timeout duration, there is still only 1 limit. There is only limit 1 per 2 seconds. But we execute first call, execute a second one, and both are successful. What is the difference? We added timeout, and you can see, simple, that there is first success, and the second success is 2 seconds later, because sometimes it doesn't make sense to reject more requests than you can support, but you can delay them at the timeout and delay, for example, to the next time window. Retry is this almost very simple and popular pattern. Often people forget that it is a pattern. What you can do with retry, of course, in case of failure, you repeat your executions. What is interesting, with Resilience4j, you can make it in a smarter way. That means your components can be smarter. Let's see the example. Okay, so our retry will retry exceptions, but only if they matches this predicate. What is it? We say retry only if there is a server error. That means HTTP status is higher or equal 500. It makes sense because if you receive 401, 403. It means bad request, yes? Please don't send it again. But if there is a server error, it means let's try again. And there we configure our server. That means each URL with ends on 500 will respond with server error, but each endpoint with ends with 400 will respond with bad request. And there is a simple case when we decorate here our method executions. We expect 500 because we call this URL. And even there was only 1 call, there are 2 more calls because we use retry. But when we try to receive some unexisting baud, for example 400, because it was bad request, there are no repeats. In third test, you can see I used here again try from waiver. And there is example that you can not only unwrap the value or exception from try, but you can also make some simple fallback, like here using recover method, and provide some dummy boat. So even there was error on server side, we receive some name, and result isn't empty. I will back to fallback. What is interesting also in Resilience4j, you can configure interval functions. Defaultly, it is constant time. That means if you repeat, again, you repeat after the same constant time. It isn't best value. Probably you should find some random function or even better expressional backoff. Because if something doesn't work now, it doesn't make sense to check it again after the same time. Let's wait, for example, twice longer and then check. And people often forget about this. Sometimes there is often no interval between calls. There is one by one and no time, no wait time between. And people also forgot about maximum number of calls. So if you think this way, you can simple ends with some DDoS. Also, big value for retry is wrong choose. And Bulkhead, my favorite one, it works similar to rate limiter because it also limits the number of executions, but not in time period, but concurrent one. So it limits executions per moment at the same time. And you can use it to protect, for example, to create some resource pool. You have limited resources in pool, and you can protect access to them. What is Bulkhead in reality? There is case without Bulkhead, and you can simply see if something wrong happened, everything sync. And there is example on the right with Bulkhead. Bulkhead is a construction pattern used not only for ships, but also for docks. And it helps to protect partially all. And Bulkhead in test. Let's imagine this situation. One boat, 20 people, and only 4 paddles this summer. And now the same for people without imagination, just in 2 methods of code. What we have? We have our limits, only 4 paddles and 20 people in the boat. And we have 2 methods. The first one is paddle now, when we create, we try to get available paddle and later return it to the pool. And we have method everybody in the boat when we create 20 tasks and start them at the same moment. So there is a first version. What happens if we add no resilience component? So we just execute both methods. So you can see that even we have only 4 paddles in our resources pool, we created and started 20 threads, this column, and the number of available paddles, which should be between 0 and 4, what makes sense, often was below 0, what doesn't make sense, because we have only 4 paddles. So maybe what we can do, we can add synchronize to our paddle now method, and to protect our resources pool. What happened? We create 20 threads. What is surprising, a lot of them try to sleep. You shouldn't never do it in the boat full of 19 unknown soldiers. And the number of available paddles is almost always free. Why? Because we can use only one paddle at the same time, because we use synchronize on our method. So rest of paddles are not in use. Wrong. Let's add thread pool bulkhead. Like in Hystrix, in Resilience4j, there are two kinds of isolation. That means thread pool based and semaphore based. Here you can see that even there are a lot of started and executed threads, there are only 4 different threads. 4 threads, what makes sense, and the number of available paddles is always between 0 and 4. Great. How we can remove unnecessary, let's say, calls? Because thread pool use queue under the hood, we can limit the number, the size of this queue to 1. It is a minimum. And now there are only 5 executions. 1 more because of the queue size. Can we do it better? Yes, we can use semaphore-based bulkhead, and it is a solution for our problem. Even here, we still create 20 threads and start them, but because we decorate them with our bulkhead, we limit everything to 4. There are still 20 threads, they are started, but they can't access at the same moment. Only 4 of them can access at the same moment our paddles. Fallback. I showed a simple example with recover from waiver library, but there is another one. Sometimes, especially if you watched the movie, sometimes it is better to receive non-swimming boat, like here, than nothing. Maybe some more realistic example. Let's imagine you are a movie platform, like HBO Go, and some of your services doesn't work. Then nothing work, like in HBO Go. It wasn't best example of resilience. So let's imagine you are Netflix and some of your services doesn't work. For example, recommendation system. It doesn't work, but you can provide fallback. For example, the list of the most popular movies. A lot of people won't see the difference. They will think that still they receive recommendation, but the recommendation service doesn't work, they receive fallback, the list of the most popular movies. I will show you Fein Decorator. It is an extension for Resilience4j. If you programmed for Android, use Retrofit or Fein, they work in similar way. That means you can create HTTP client just from simple interface. In declarative way. And why? Let's see the code. Okay, short introduction to Fein. What you need to create HTTP client is to provide plain old Java interface. It only contains endpoints declaration and some HTTP annotations, and it is enough. It is ready to use, and you need to choose decoders and encoders. For example, JSON for JSON, and that is all. But you can also decorate everything with Resilience4j. You can add a red limiter, fallback, or circuit breaker. How works fallback? Here again we use this predicate. That means our fallback will work only if there is a server error. No client error, only server error. And here is another alternative implementation of this interface. Okay. And what does this fallback mean? Instead of error or 500 status, we will receive for list of boats empty list, because it is better to receive nothing than error. Instead of null or again 500 exception, when you try to receive some boat, you will receive some dummy boat. For in our case, it is some kind of live raft. And that is enough. Now we can use our decorated API. Now you don't need to decorate each method, because all API was decorated. And here you can, there is example of fallback. There is an error because our mocked server always responds with error. But even though here we receive some response, our fallback one, and there is a boat with this default name. There are more extensions for Resilience4j. For example, if you don't like functional interfaces, decorations, or builders, and you are fan of annotations, reflections, and aspect-oriented programming, and you choose Spring, you can use extensions for Spring or Spring Boot. And instead of decorators, use annotations or properties file. If you program in a reactive way with Reactor or RxJava, you can use operators or transformers, reactive ones. And there are also extensions for other frameworks and metrics libraries. I will back to metrics because it is important. And now the most popular pattern. If you heard before about resilience and hystrix, you have to heard about circuit breaker. What circuit breaker do? It is an opposite of retry. That means in case of failure, we don't repeat our call, but we disable backend and we enable circuit breaker, make them active, and disable our backend or our other service. So you can think about circuit breaker as if it were a failures cache, because we cache failures. We don't allow to next failure call. Do you remember this picture? It is a logo of Resilience4j, but it is also a diagram of circuit breaker. Let's remember 3 words. There are only 3 states in circuit breaker because it is finite state machine. Closed, open, and half open. How they works? Let's see the code. It is the most complex one, but I will explain line by line. So, our server is mocked, and in this test always respond with error. It doesn't work, never. There is our circuit breaker configuration. This value for now are unimportant. And here we also capture events from this component. All Resilience4j emits metrics and events, and you can metrics are often used to metrics, but you can do anything. You can for example, use them to verify behaviors, like in this test. And here, like in other cases, we use our boats API and decorate it with circuit breaker. And then it's time for test. There are 10 calls to our decorated API. Next, there is some short break, and again 4 calls. And even there are 14 calls to our backend, at the end, there are only 6 calls. What happened? So, here is our 10 first calls, but after 4 of them, because our server doesn't work. So, after 4 is from the configuration, it is rank buffer size in closed state. After this number of calls, our circuit breaker can check, hey, how many errors were until now? Because if there were more than threshold, it's time to open circuit breaker. And it happened because all of requests were errors. So now circuit breaker is open and backend is closed. That means that next calls won't reach our backend. They are blocked. Yeah, like a circuit breaker in real life. And now, after some time from our configuration, circuit breaker can ask another question. Maybe it's time to finish work of circuit breaker. Maybe our backend or server return and now works. And in Hystrix, there is only one call permitted to check it. In Resilience4j, there you can configure the number. In this case, there are 2 tries. Of course, this configuration is only for test. Normally, you should use higher values. So we permit two calls. They aren't blocked anyway, but because our server doesn't work always, he never works, our circuit breaker back from half open to open state, and again nothing is permitted. How long? For next 100 milliseconds. And as I said before, even there were a lot of calls, our server had time maybe to be rebooted, maybe there was a time for load balancer to switch to another instance, maybe some auto-scaling group from AWS. We don't make DDoS on our own resources. If something doesn't work, there are 2 popular strategies. You can retry or you can disable it. And circuit breaker is the second approach. Cache is also a popular one. Resilience4j doesn't support cache, but it handles popular implementation of this standard. So if you use any of them, you can simply add cache to your resilience layer. I will show you not how cache work, but what decorator means, because before we always decorated only one resilience component, but here are more. That means there is our server, HTTP 1, there is our API, circuit breaker, retry, and cache. Here. And how it works together, how we connect all of these layers. You can use this approach, but there is only one good thing. That means there are no local variable. So instead of nested decorators, maybe use some explicit decorators like here. So what do we need? You can think about Resilience4j as orc or ogre. He has layers. The last one is our API, because it is what we want to achieve. Here is a retry. Next we add a retry. Next we decorate it with circuit breaker. And at the end we decorate it in cache, with cache. And how it works? The order is reverse. That means first we read our cache by this key. Next, if there is no value in cache, next is use circuit breaker. If circuit breaker is closed, it allows call executions, and next is retry. If there was a success, retry isn't repeated, because there was a success from our API. You can also connect them in some more functional way, like this. That means you can compose them, and then But you can also use probably the best approach, that means this decorator builder, when you add each decorator in other method. So, in contrast to Operation Dynamo, which took 8 days and was real hell, you can think that resilience components, especially if you use ready-for-use components like this from Resilience4j, they are simple, because they are. There are 2 or more problems. First, when to use them and how to connect them, how to put them into your system. And the second is that there are more of them. What I showed you were simple patterns for code base layer. That means you can add them and use in your code, but there are more patterns, and they matches better, for example, with containers, with API gateway, service mesh, or even with your cloud provider like Elastic Load Balancer from AWS. So it is just a beginning of your resilience adventure. What should you remember after this talk? Nothing from this list, but it is good to know that the length of the smallest boat used in Operation Dynamo had 5 meters. They were private boats. There were a lot of them. So, what should you remember after this talk? First, don't apply every pattern, not only because you can and because it is simple, but they doesn't work in the wrong order. Let's imagine what happened if you connect retry and circuit breaker, if you connect retry and cache. If you do it in the wrong order, it doesn't make sense. Don't decorate everything, not only because you can use configuration file or annotations, but because often it is better to fast fail than fail safe. It is good to know when something doesn't work. Of course, fallbacks are great, but if you can't use them in each situation, sometimes you need to stop and break. And you need to use metrics. Why? Not only for colorful dashboards, not only because each component emits a metrics, but because you need to tune your configuration. You don't know which values are best for your production system, so you need to change them after some time of work. And even my examples, you remember this boats API, even they were related to HTTP client, it doesn't mean that resilience components or patterns generally are only for HTTP or network. Everything what depends on time, threads, some resources, external services, everything what is unpredictable, everything what is stateful can potentially fail. And probably it needs some resilience protection. That is all for me. Thank you for attention. Just a few words at the end. Forget about agile, just be resilient. Thank you.